Okay, great. Now we're recording. So last time we talked about measures of central tendency. Mean and median were such. Mode is also one such measure of central tendency. We will get into range, quartiles, variance, and standard deviation later today. That's on measure of dispersion, which is more about spread. Again, the mean is just we add up all the data points and divide by the number of data points. Very simple. Usually we use X bar as a symbol for mean. This right here is called sigma, and that indicates summation. So when you see that, that means you're adding up a bunch of data points. So you can express this more concisely by doing sigma xi, where the subscript just indicates what x value you're doing. Like x1 is the first data point, x2 is the second data point, and so forth. Medians, very straightforward. As long as you have all of your data points in numerical order, in other words, right smack in the middle is going to be your median. If you have an odd number of numbers, that's it. If you have an even number of numbers, then of course you average the two middle numbers. A resistant measure, we didn't really get too deep into that, but that's just basically a mean. It's just a measure where it's resisting extreme observations. So basically, if you remove extreme observations, then that's kind of what you would call your resistant measure. We're not going to really talk too much about that, but we do want to be able to recognize outliers, numbers that are out of what we kind of expect to happen. So we'll have that discussion. Location, mean, and median functions on a TI-84. We're going to use Excel instead. I think that's just going to be more efficient, or a Google spreadsheet, which that's free. Everyone should have access to that. It's really easy to use. Ultimately, I think we're going to want to have Microsoft Excel when we start doing more sophisticated stuff, because the Google spreadsheets is a bit limited. But for now, what we're doing, Google spreadsheets will do. When you compare mean and median. Okay, so we didn't quite get into that. So we're going to start talking about that today, and then spreader variability. So we'll start up with the comparisons. And we're actually going to do a little activity, which I think will be kind of neat. So anyway, comparing mean and median. So if I read the first bullet point, the mean and median of data from a symmetric distribution should be close together. The actual true mean and median of a symmetric distribution are exactly the same. So what's meant by symmetric? Symmetric means that your data points, if you're doing, say, a bar plot, so say this is frequency, how often something happens, and say we do, let's do test scores. I know, not terribly exciting. And let's say we do a range of test scores. So those that score from like 0 to 20, 20 to 40, or 21 to 40, we'll say, 41 to 60, 61 to 80, and of course 81 to 100. And this would be an example of a symmetric distribution. So you see that if I were to slice this in half, the left side would be a mirror image of the right side. We also just like to say it has a nice bell-shaped curve. And we see that it's equal on each side of the middle. So that's what's meant by a symmetric distribution. Now, in real life, you're not going to get that all the time. You like to try to get as close as possible to look like this, because then it makes your data more predictable. But sometimes you have data that we call is skewed. And skewed means it could be pulled in to the left or to the right, mainly because you have outliers. So we're actually going to explore skew in just a little bit. Actually, let's do this. Let's take a look at recent home sales. So this is always a fun activity. So we're gonna have a little fun here. We're gonna go to Zillow. Don't mind this. This is actually my parents' old house. They sold their house a few months ago, and someone flipped it, and they're not having any luck selling it. So let me just close that down. Looks a lot nicer when my parents were living there. My parents didn't do a single thing to it for 17 years. Anyway, so let's take a look at 94062. Actually, no, let's do San Mateo. Actually, we'll do San Mateo, California. And what I'm going to do is I'm going to clear my drawings, and we'll say sold. So I'm interested in homes that have sold already. Now you obviously see a bunch of homes that's, showing 3,000 homes. That's a lot of data. But we're going to make this a little bit more tight, our data here. So let's say we're looking at homes that sold in a certain square footage range. So now you can see that it dropped to 580 results. We could probably make it even tighter. Homes that sold probably in the last 6 months, let's say. So now it's down to 81 results. If we make it even tighter, we could say lot size are a quarter acre. So you only have 16 results. So what I'm going to do is I'm going to make a data set for these houses. So 4, 6, 8, 10, 12, 14, 16. So now I'm going to go to, and I'm going to share this with you guys. So I'm going to make a new spreadsheet here. And we'll label this September 10th statistics activity. This way you guys have access to it. And we're going to do sale price. And actually, sometimes it's also good to label a bit more. So this will be sales of houses in San Mateo, 2,000 to 3,000 square feet, quarter acre lot, last 6 months. So basically March 10th, September 10th, 2020. Okay, this way we kind of know what we're working with. So always good to kind of do some sort of labels and stuff like that. That's good. That was always good practice. Then we see the home prices. So I'm just going to kind of tap as a decimal for now. So we'll do, so 2.55, 1.25, 2.2, 2.1. And usually when you do this, even though it's nice to kind of have a data set, it really kind of gets you more intimate with the data. Sometimes I like to say like I'm like really getting in touch with the data. It's kind of like if you're making a meal, sometimes you can follow a recipe or you can kind of do your own thing. Sometimes you do your own thing, you really feel like you're taking ownership of it, right? So I think this is like we're kind of making a meal here. We're just getting really in touch with the data. So as I'm putting these numbers in, I'm just realizing these are, very expensive homes. And I realized, wow, one house, or is an apartment. So we're looking at apartments to 2.1. Okay. So we have our sale price for 16 homes. So now what we're going to do is we're going to calculate the median and the mean. And really simple. Do equals median, highlight, 2.225. Now if I do the mean, I need to type average. So you notice the mean is a little higher than the median. Anyone want to explain why that might be the case? Why would the, so they're not exactly the same, obviously. And they're off by quite a bit, by about $120,000. Because remember, these are in terms of millions. So this is $2,225,000. This is $2,343,000 and 75 whatever. So what's causing this mean to be a little higher than the median? What do you guys think?
Well, the median's an average of like just 2 points right in the middle. That means the average of everything.
So let's rank this data. It's always good if you can rearrange your data. So if we rank it, we see that we have a total of 16 homes. So as Will just said, if we have 16 homes, that means the 8th and 9th homes will be our median. So it's going to be average of those two. That's what Excel just did for us. Now, if we kind of think about it, we do have some data points that are pretty high. Like there's a house that sold for 3.62 and a house that sold for 3.6. So what happens is that those very two expensive homes pushed the mean a little bit more to the right. So when you actually were to, if you actually were to do a bar plot, let's say for this, it's going to be a little bit tricky to do here. I'm not too familiar with doing graphs on this, so it might be a little bit easier if I do it on a regular Excel program. Plus, I think we have to decide how we want to break up the bar plot. So I'm not going to do that right now with you guys. But if you were to kind of do a quick sketch of your distribution, it's going to look kind of like this. And so we say this is skewed to the right, where this right here represents house prices. And this represents frequency. Obviously, I was very selective in how I chose the house. I didn't choose a bunch of houses. Probably better if I did. But this also gives an idea, like if you're looking to buy in San Mateo, and you're looking, I need this about this much space, this big of a lot. What have the recent sales have looked like? Someone would say this is what you need to expect to pay. But when someone says it means a little high, they say, well, that's because there are some homes that are pretty expensive. People paid quite a bit of money for. So those two homes caused the mean to move a little bit more to the right. Now, on the flip side, you get something that's called skewed left. Skewed left would be something like this here. Again, we're doing frequency and house prices. And so what happens is that majority of your data is going to be on the high end here, not too much over here. So there might be maybe one house, like I could actually alter my data a little bit. What if this house sold for like hardly anything? Let's say it sold for like $100,000, so 0.1. And let's say another house sold for that as well. And so did another house. All of a sudden now it means less than the median. So you have 3 homes that sold for very cheap compared to the rest of the homes. So that now causes the median to now shift to the left, because those data points are those 3 really low data points are causing the data to move to the left, or it's causing the mean and median. The median is still the same, but causing the median to move to the left. So that's an example of skew. And so that's just kind of like a real life example, looking at sales of homes in San Mateo. And you can kind of see, they even show you kind of like a nice, map there where the homes are located. And sometimes you could even kind of click on the homes to kind of understand, like, okay, like this house here, like where is this house? Okay, maybe it's over here, or it's an apartment, so that's why it's probably a little lower. But sometimes you could see like, oh, some homes maybe went for a lot of money. Maybe they're up in the hills, have a nice view, or some or might be close to Highway 101 or El Camino, or close to the train tracks. So you know, some homes might be, you know, in the better school district. So sometimes, you know, you have to kind of like dig a little deeper to get a deeper understanding of the data. But I digress. So anyway, so that's what's meant by an skewed distribution. The mean is farther out in the long tail than is the median. So the mean is pulled in the direction of the possible outliers. So we just had that discussion. Now, spreader variability. So if all values are the same, then they all equal the mean. There's no variability. Obviously, you know, like let's say I give a test. Let's say everyone gets a 90. Each person gets a 90%. There's no variability in the data. There's no change. But variability will exist. And obviously, they could be above or below the mean. So in order to get a good understanding of the variability of your data, we like to look at a few quantities: range, quartiles, variance, and standard deviation. Range is very, very easy. It's just the max minus the min. So going back to what we just did, and I'll share this with you guys. You know, obviously my range. So you just do equals max. I mean, it's pretty awesome what the max is. I know it's 3.62, but you do minus min. But what if your data is not ordered, or what if there's just a lot of data points? You can just do that, and that gives me my range. So the range here was $2.62 million. So really easy calculation. And it is strongly affected by outliers, because if you do have a data point that's really low, like if I go back again, let's say I make this like 0.1, then you can see my range changed by a lot. So change means some, obviously, but it changed the range quite dramatically. Or let's say this now became like 5, you know, obviously the range changed a lot. So range is strongly influenced by outliers. Remember, outliers are anything that's out of the ordinary. Let's keep moving. Quartiles. Now, quartiles are kind of important to kind of get a feel for where the data, or where, like, you know, if you're selling your house, or if you are submitting an SAT score to a college, like where does your score fit in the range of typical scores, or you know, where does your house fall in the range of typical houses if you're selling a house? So 3 numbers which divide the ordered data into 4 equal sized groups. You have the first quartile, the second quartile, and the third quartile. The second quartile is simply the median. It's right at the 50% mark. The first quartile is at the 25% mark. So, and then third quartile is the 75% mark. So looking at our data, actually, we're very lucky that we had 16 data points. That wasn't intentional, just happened. We got very lucky there. So if you think about it, this is going to be, because I have 16 data points, so I'm going to highlight. That will be my first quartile. This will be my second. Hold on. Guys, Excel, not Zoom. That's my second quartile. That's my third quartile. And that's my fourth. So basically, you're breaking this up into 4 groups. Now, more specifically, Q1, Q2, and Q3. Q1 is going to be the score that's right at the 25 percentile, meaning that it's higher than 25% of the data points. That's what Q1 represents. So Q1, 25% of data points are below it. Q2, 50% of data points are below it. Q3, 75% of data points are below it. So I did make 4 groups, but what I'm really looking at for Q1 is between those 2 numbers. Q2, between those 2 numbers. And Q3, between those two numbers. Now you can actually compute it in Excel. All you just do is you do quartile, and you select your data points, and it gives me the first quartile. So notice it gave me 2.08. So basically what it's trying to do is it's trying to compute what would be a data point that would represent that would be higher than 25% of my data points. 25% of my data points are less than 2.08. The second quartile, so one thing you could do in Excel is you can always copy and paste. Now it does change these cells here. So one thing you could do, if you put a $ next to the letters and the numbers, it won't impact them. So then if I just drag it down, you keep those intact. Now I want the second quartile, which was my median, 2.225. And if I want my third quartile, change it to a 3. And that's essentially in between those two numbers there. So in how it's calculated, it's a little tricky, but essentially it represents a number that's higher than 75% of my data point. So it's not, so 2.825 is not exactly halfway between these two. It's kind of assuming some sort of distribution, which I'm not going to get into just yet. But that's something you can do to kind of make this easy for you. So that's how you would calculate. So the first quartile is 25%, this and this. You could also do percentiles. So if I highlight the data again here, I want the 25th percentile. Sorry, I should put 0.25. Get the same thing. And then let me put $ here. Again, I'm recording all this, and I'm going to share this with you guys so you guys have access to this. Oh. And if I drag, so I want the 50th percentile, 75th percentile. So it gets the same thing. So you could also do that as an option too, percentiles. So Excel is going to be kind of your best friend here, or a Google spreadsheet, which is kind of like Excel. You can change this up to any kind of percentile you want. So for example, like some of you guys, I know many people have not been able to do the SAT or ACT, but a lot of times when they say like, oh, you got like, 80th percentile, it means your score was better than 80% of people who took the test. So if you had all the data points, if you had all the SAT scores in the country, and then you put like 0.8 as percentile, the score that comes out will probably be the score you got if that's what was reported on your score report. So percentiles simply represent how your score compares to all the other data points. That's what a percentile is.
Mr. Almashny?
Yeah, go ahead.
How different will this look in Excel?
It should be the same. I mean, if I open up Excel right now, it's just Excel has more features that are more sophisticated, which we will get into later in the course. So my Excel's a little slow because I actually have an optimizer in here from one of the data science courses, which I haven't removed. And so it likes to take a sweet little time. Usually I like to keep a spreadsheet open so that I don't have to reopen the actual program, but let's wait. It's thinking. Probably I'm running Zoom too. There we go. Okay, great. So what I'm going to wind up doing is just copy and paste my data. Now I didn't copy the formula over. I don't know why I didn't do that. But if I were to do like equals median, same thing, right? Highlight. So I was able to replicate that. Or for Q1 equals quartile. And in this case, so you have to give the array. So the array means like what range you're looking at and what quartile you want. I want the first quartile. So give me a little bit different value. I don't know why the value is different there. What if I do, okay, so inclusive. Actually, let me understand why it's doing that. Let me look at the explanation one more time. So quartile returns a quartile data set based on percentiles from 0 to 1 inclusive. Okay, I'm sure we want to be inclusive. I don't know why you want to do the exclusive one. This one's a little bit older, so we'll use that one. I guess it's a little more updated. Now, if we do percentiles, that should be the same thing. And I assume we'll probably want to do the inclusive one. So we'll go with that one there. We'll select our array, which is our range of values. And I want the 25th percentile. Oops, remember I got to do 0.25, my bad. Yeah, same thing. So it's not that much different, not at all. So, but there is that little nuance with the inclusive and exclusive. You want to use the inclusive one. But the other one should be like here, like, you know, max, same thing. Minus, min, same thing. So, not too bad. Okay, let's go back to our notes again. So that's how we do quartiles. Now, interquartile range is when we subtract the third and first quartiles. So it gives a measure of the middle 50% of your data. So in this case, you know, this is my middle 50%, the orange and the green. Orange like the sky, not quite orange today anymore, which is good. Yesterday was absolutely nuts. But yeah, interquartile range. Actually, why am I back at Excel? Yeah, over here. So your IQR, which is essentially just Q3 minus Q1. And so you could just say, hey, I just want to subtract D9 minus D7. So D9 minus D7. Interquartile ranges actually are very, very relevant for those who are applying to colleges. They tend to give interquartile ranges for like GPAs or test scores. Again, test scores may not matter so much anymore because a lot of schools are going test optional. So, you know, we're in a very rare circumstance with the college admissions landscape. But, you know, when you're looking at colleges that you might be considering and you want to see, you know, how does my profile kind of fit? You know, sometimes it's kind of good to look at the interquartile ranges because, you know, is your score representative of the middle 50% of students who typically get into that school, right? And college counselors tend to consider that. They want to make sure that, you know, you're applying to a school that you might have a chance getting into. So for example, it says find the range quartiles and interquartile range for commute times in example 1. So I think this will be a great opportunity for you guys to go into breakout rooms, make sure you're comfortable doing this. So what you're gonna have to do, I think we could actually, I can copy and paste this. Let me see if I have any luck here. If I can, then I'm going to do that for you and I'm gonna share a spreadsheet. So I'm gonna label this as home sales. I'm gonna create a new sheet. Don't need that one. I'm gonna call this commute times. Okay, so the data came out like that. So it came out a little weird. There's a little trick you can do. You could actually, wonder if I can find it on here. You could actually shift text to columns. Yeah, split text to columns. And then spaced out. Okay, so notice that what it did was it took my data and put it all in columns. The only thing is it's a little annoying because I really don't want like one row and a bunch of columns. So then you could do something called a transpose. And let me see if I could locate that here. Sometimes you can do that. So if I do copy, paste special, paste transposed. So that's another little trick you can do to make it a column. So now I'm going to delete that row. So, and then this is commute times New York. Sorry, commute times. Let me add another couple rows here. This is going to be North Carolina. This is going to be New York City. Make that nice and bold and underlined. And if I go to the other data point, or data set, sorry, do that. Go back to, come on. Got too many windows open. So again, I'll paste special. And actually, I should have paste transpose right from the get-go. Okay, I didn't like that. That's because actually it's all in one text. So I have to do that. If I copy and paste here, paste transposed. Okay, I didn't do that either. I didn't like that as well. So I need to shift this to columns. Sorry, so let me back up a little bit. So all I did was I copy and pasted this. Copy. And just, you can just paste it, it's just fine. And then if I go to data, split text to columns, and select space, because you want to have it, anything that's separated by a space, you want it to be put in separate columns, which it does. And if I highlight these cells, I'll do a Control-C for copy or Command-C for your Mac. Then if I right-click, paste special transposed, there you go. Of course, it overwrote some of them. Not a big deal because I wasn't interested in seeing those. I want to get rid of that anyway. And if you just backspace, it clears all that out. So what you guys are going to do in your breakout rooms, you have your data. Let me share this with everybody too. That's important. So let me just. So John's just going to just do your name here because I obviously have sent an email to everyone in this class before. Let's see, and I'm going to throw you in here too, Will, so don't worry. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, sorry, I'm not going to put your mom in there. Unless she wants to do this in the class, she can join us. Sorry. Okay. If I go here, share. I wonder why. That's weird. I created a new spreadsheet. I wonder why. Maybe because I was in the folder of these old teachers. That's strange. I don't know why they're there. And then I put you in here, Will. And I'll make you guys all editors. Actually, no, because I don't want you messing the data. Who's you guys viewers? Here we go. Okay, so if you go to your emails, you should have access to the file or to the spreadsheet here. So what you guys going to do in your breakout rooms is you guys are going to do what I just did. You're going to calculate the range, the first quartile, second quartile, third quartile, the interquartile range, and you could probably put it all down here. So we're not going to do this in the calculator. We're going to do this in Google spreadsheet. And again, you have access to home sales, you have this axis here. So you actually have the formulas here you can copy and use. So it should be hopefully pretty straightforward. I'm going to hop in the groups and help you guys out if you're a little bit stuck. We do have 9 people, which is actually a pretty nice number. So I do 3 groups of 3. So let me stop sharing. I'll stop.